Hi, my name is Jesus Mares and I work at the National Polytechnic Institute in Mexico. And I'm going to present the work entitled A Study of the Effects of Curing Time on the Mechanical Behavior of 3D Printed Parts with Standard Resin. First, I want to thank on behalf of all my working team to the committee of the ACEX Congress for the opportunity to present this work. The printing of parts with photopolymers like resins is particularly important as it can be used for visual and functional prototypes, medical devices, casting patterns, or aerospace and automotive parts, among others. During the printing process, there are several variables that could affect the final mechanical performance of the parts. These variables include, but not limited to, exposure time, layer thickness, part orientation, or light source power. Another determinant parameter regarding the final mechanical behavior is the curing time after the printing. Although several studies related to the evaluation of the mechanical performance of the printed parts have been published, it's noteworthy that a large majority of these studies focus on the tensile behavior of thermopolymers processed by fused material deposition methods or on metallic alloys processed by powder sintering methods. Regarding photopolymers, there are some studies under mechanical characterization focusing on the effect of the printing parameters on its performance. The reported results suggest that one of the most influential parameters of the mechanical performance is the post-printing curing time. Given this, the problem to be addressed in this work was the characterization of the tensile and shear behavior of 3D printed parts with standard resin through a stereolithography method, and how this is affected by the variation of the post-printing curing time. For this work, we built 42 specimens, test specimens, with standard resin through SLA method under conditions of controlled temperature, washing time, and post-curing printing time. The post-curing printing was done through a UV LED power source of 60 watts at 38 and 405 nanometers with varying times from 0 to 6 minutes. The ASTM E143 and the ASTM D638 standards were used as guidelines for the torsion and tensile test respectively. Torsion tests were carried out in experimental test bench Gant Hamburg WP510 with 200 Newton per meter motor drive at 50 RPM per minute test velocity, while the tensile test was made with a Shimatsu AGS 50 universal test machine with a maximum load capacity of 50 kilonewtons and at the speed of 1 millimeter per minute. From the test performed, it was concluded as expected that better mechanical performance was obtained when the post-printing curing was done. It is noticed that all the tested specimens show a clear linear response and the shear strength was increased with the post-printing curing time. When comparing to different specimens that were cured during the same amount of time, the results show consistency for both torsion and tensile test. Post-printing curing time has significant influence on both tensile and shear behavior of the printed parts, while asserting that even with short curing times, a significant increase in shear strength around 30% and tensile strength around 60% increase are obtained against the strength without post-printing curing. Then it can be concluded that short curing times can be suitable to attain better mechanical performance while reducing energy consumption against longer curing times. Also, it's worth noting that the failure of the torsion specimens show a sudden high-speed crack propagation in multiple points, while the failure of tensile specimens was located in a single point in the narrow section of the test specimens. Thank you for your attention.